Our last two questions, questions 15 and 16, ask us to integrate by substitution and integrate by parts. Integration by substitution is a sort of undoing of the chain rule, and integration by parts is the reverse or the undoing of the product rule. And so to integrate by substitution here in question 15, what you're doing is you're looking for a composition in the function that you're integrating, and you want to see if you can locate the derivative of the inner function also contained within the entire integral. And we can see fairly easily that the inner function in this expression in this integral is x cubed plus 7, and we can furthermore see that if we differentiate that, that's 3x squared, and that is also found in the integral. So we let u, and it could be any variable, but u is customary, we let u equal x cubed plus 7 as our substitution, and then differentiating both sides with respect to u, we have du, u differentiates to du. The right side, even though it's not as obvious as all that, the right side gets integrated using the chain rule. So we use our power rule on this, or it's differentiated rather using the chain rule. So we differentiate this term, and that's 3x squared. But then we differentiate the inner function, which is just x, and that gives us dx. And we can see that 3x squared dx is within that integral. So when we substitute the u for the x cubed plus 7, we also substitute the du for the 3x squared dx, and our integral now becomes the integral of 1 over u. And it's an indefinite integral, so there are no limits of integration, top and bottom. Well, the antiderivative of 1 over u is natural log of u, and then we, of course, add the constant c, and finally substitute back the x cubed plus 7 for the u, and this becomes our final answer. So that's all well and good, but on your exam, your question 15 will take this form right here. This will be exactly, these are the exact steps that you will want to take to integrate this function on this question on your exam. It will be e raised to some power times x, or some number times x rather. And so your exponent ax is what you substitute u for. So we let u equal ax, and then differentiating both sides with respect to u, we have du, and a is the derivative of ax, but then we take the derivative of the x, which is dx, so du then equals a dx. Multiply both sides then of this equation by 1 over a, and that gives us 1 dx over here, and 1 over a du over here. And so when you substitute, you're substituting the 1 over a du for the dx, and the u for the ax. And since multiplication is commutative, 1 over a eu du is the same thing as e to the u times 1 over a du. So all I've done here is sandwich the e to the u in between the 1 over a and the du. And because this is just a number, we can factor it outside, or we can factor it outside of the integral. And since the derivative of e to the u is just e to the u, then we can take the integral sign away and add the constant c, And so we have 1 over a times e to the u. And then bringing the e to the u into the numerator, multiplying times this 1 over a, and then substituting the ax back, we have our final answer, e to the ax over e plus the constant c. If you write all of these steps, how many is that? Let's see, 1, 2, 3, 4, 5, 6, 7. If you write this integral and these 7 steps down in your exam notes, I don't really see how you could possibly get this question wrong. Just substitute the number on your exam question in for the a throughout here, and you'll get this question right. The integration by substitution is a little more complicated, but notwithstanding that fact, I've given you here a very clear set of steps to use to perform that integration. And as I said before, integration by parts is an undoing of the product rule. And so we see x to the 6th times natural log of x as a product, and I showed you in class during the review how we use the product rule for differentiation to derive this formula for integrating a product. And so we will want to designate g prime and f as one of these, so we would choose natural log as g prime or x to the 6th as g prime, and in making that choice we choose we choose f so that f prime is a simpler expression than f, and we choose a g prime so that g is not much more complicated than g prime. And in this case, since the antiderivative of natural log is very complicated, we choose g prime equals x to the 6th, and so the antiderivative of g prime is 1 over 7 times x to the 7th, because we add 1 to the 6th, that's 7, and the reciprocal of 7 is 1/7, and so this then 1/7 times x to the 7th is our antiderivative of g prime. Now the f is our natural log of x, the derivative of natural log of x is 1 over x, so those are our 4 substitutions, and we substitute those into this formula here. So g prime is x to the 6th, so x to the 6th goes here. F is natural log, so natural log goes here. Then on the right side of the equation, g is 1/7 x to the 7th, so g here. And then f is natural log of x, so that goes here. Then we subtract the integral of f prime, which is 1 over x, times g, which is 1/7 times x to the 7th. Well, the x goes to the denominator here, the x to the 7th to the numerator, and one of the x's in the x to the 7th cancels with the x in the denominator, and so that makes the integral now x to the 6th over 7. And then in our next step we take the x to the 7th and the natural log and bring them up to the numerator, and we antidifferentiate, we integrate the x to the 6th over 7, so 6 plus 1 is 7, and the reciprocal of 7 is 1/7, and so there it is, 1/7, and when that's multiplied out, that gives us a 49 in the denominator, and then of course we add the constant c, and so here's our final answer. Now the abstract of this, which you will want on your exam notes, is x raised to the n, some number n, times natural log of x, and so then you would then following this pattern, you would on the right side of this equation multiply 1 over n plus 1, whatever n is, this is just one larger, times x raised to the n plus 1, natural log, minus the integral of 1 over x times 1 over n plus 1 times x raised to the n plus 1. Now, in addition to these steps here that you would want in your exam notes, you might also want to identify, as you answer the question, that is, you might want to identify the function and functions f and f prime and g and g prime using these abstract representations. Or, well, actually, in answering the question, we wouldn't be using the abstract representations. You would follow the example of these abstract representations. And so that's how you would fill in all these expressions, and the steps then that follow match this example, and our final answer is shown here. And again, if you write all of these steps down on your exam notes, in addition to reminding yourself that while answering the question you should identify the f prime, the g prime, and the g, then again I think you should be able to get this question right without too much difficulty.